Well, thank you there so much for joining. My name is Francesco. I lead the cloud team in Android, and today I'm going to talk about Google Cloud Messaging. Last summer at Google I/O 2012, we launched this service to bring the old cloud-to-device messaging system, also known as C2DM, out of beta. And along the way, we made a lot of improvements. We made it faster, we made it more reliable, we made it more scalable, we removed quota limitations, we opened it up to all of you, we added a bunch of new APIs. We must have done something right, because the adoption for a new system has been fantastic. But before I jump into that, I really want to take a moment to thank all of you that today use Google Cloud Messaging in your application, because it really helps the ecosystem by reducing the impact that your application has on battery life, network signaling, the amount of data that goes over the wire, and in general, it improves the user experience by providing fresh and up-to-date data for your users. So back to the adoption. June 27, 2012 is the day we deprecated C2DM. From that day until now, well, Google Cloud Messaging experienced an impressive 400% growth. And this growth accelerates every single month. So in April, we were already processing over 200,000 queries per second. And if you build a list of the most popular, most downloaded applications on the Google Play Store, including those that have nothing to do with the cloud, well, that over 60% of those today use GCM. So I wouldn't be surprised if many of you in this room already have an application published that uses Google Cloud Messaging today. So anyone. And that is beautiful. So for those of you that are not yet familiar with this product, let me quickly go over Google Cloud Messaging to tell you what this system is all about. Well, bottom line, if you have an Android application and you have a server and you want to exchange data, that's when you want to use Google Cloud Messaging. Today, for our example, we're going to use a surfing application. So the surf server just detected there is going to be a massive new swell on the Pacific that's going to interest the whole west coast of America. So we're going to tell our users, you got to get ready because surf's up. So the surf server opened an HTTPS connection to GCM, and the first thing we do is to store the message on the cloud, so even if the device is offline, as soon as it comes back online, we can deliver the message. Well, there are two main ways in which you can use GCM. The first one is what we call send to sync. So imagine that there is a surf contest, O'Neill Cold Water Classics. And so there are professionals, there are photographers, there are a massive number of pictures and videos uploaded on the server, and we want to tell our Android application users to connect to download this media. So we send the message via GCM, goes down to the application, and now the application knows to connect back to their own server so they can download the data and consume the media. But there's another way you can use GCM. So there is this new swell on the Pacific, and we want to tell every single user, well, in your particular favorite spot, then the wave size is going to be 6 to 8 foot. So we want to pack this data into the message and route it down to the application via GCM, so now the application can consume the data right there without having to connect back. Now, GCM also provides a bunch of APIs to allow developers to control the flow of the message. One of these APIs is time to live. It allows you to set an expiration time for your message. So imagine that the surf server identified that on my personal favorite location, now because of the tide and swell conditions and wind conditions, is a perfect time to go surfing from now for the next hour. But too bad I'm here giving this talk, so I can't go surfing. And in a couple hours when I open my device, I probably don't need to see the message. So if GCM detects that the message expired before the device comes back online, it simply drops it. Another neat parameter is delay while idle. It gives you the ability to specify some sort of priority for the message. So it's kind of like you can say to GCM, hey, even if the device is connected, but the user is not looking at it, don't bother sending it down. And these two parameters are really powerful in combination because it gives the message a chance to expire, even if the device is connected. And then we have multiple senders. Well, our server is brilliant at detecting the wave size based on the tide and swell conditions and geography of the place. But it doesn't really do a good job with the wind. Luckily, there is another service that knows all about wind conditions. So now our application at registration time can tell GCM, hey, look, I want to receive messages from both servers. And so GCM knows that both servers are allowed to send messages to this one application. And then there is message multicasting. So to send messages via GCM, you have to use an open HTTPS connection. Now, you want to reach all your users at the same time. Well, it started becoming complicated to open as many parallel HTTP connections. So to alleviate this problem, we decided to allow you to set up to 1,000 recipients in one request for one message. And then there is more. There is message recollapsing, there is message repayload, there is dry run, and you can read and learn all about this at developer.android.com under the Google Cloud Messaging section. So last summer, when we launched GCM, we knew it was just the first step. Today, I'm going to have a series of announcements that will bring the mobile cloud messaging space to the next level. And without any further ado, let me introduce our brand new service, which is Google Cloud Messaging XMPP Endpoint. So I was just talking about how multicasting allows you to send this one message to all your users in a better way than spawning all these parallel connections. But what if you want to send multiple different messages customized to all your users at the same time? Again, there is this swell, and we're going to tell all our users that have at least one favorite spot in the coast on the west. That surf is going to be based on their abilities, based on the condition of the tide and the wind, what they're going to do. So we made this little experiment, and we were streaming messages with the HTTP interface sequentially. And the maximum speed that we reached, thanks to our low latency, which, by the way, dropped to 60 milliseconds, down from 95 milliseconds when we launched the service. Also, using all kinds of improvements like SSL caching and whatnot, we reached the speed of 13 messages per second. Now, we made the same test with our new XMPP service. And now we decided to limit the speed to 4,000 messages per second. So let's look at this. Now, we have a surf server, which has a persistent connection established with GCM, and now the device is connected to it. And just like with HTTP, you can stream a message down via this channel. Now, we picked XMPP because it's a very robust and flexible protocol, and it's also widely used, and there are multiple libraries and multiple programming languages that will help you deal with the low-level details of this protocol. But the real application protocol is the same exact JSON you use today to send messages on HTTP. In this slide, I'm going to use a simple Python XMPP library. And as you can see, the URL of the new service is gcm.googleapis.com. The port is 5235. And what I'm doing here, I create a client, I connect, and then last line in bold, I authenticate. And even this should sound familiar to you, because the authentication uses the very same username and password that we use to authenticate every single HTTP message today, which is the project ID and API key. So these are the standard that goes over the wire. You can see the base64 encoding of the project ID and API key, and then the success response stanza from GCM. So now you have an established persistent connection between your server and GCM, which is authenticated, and the only thing that is left to do is stream down messages as fast as you can. Well, for messages, we use the classic message XMPP stanza. There is seriously nothing interesting to look here. The only interesting part is JSON, which should really sound familiar to you. We use the data, the collapse key, the time to leave, delay while idle, and the only two little differences are those in red. The first one, the to field, just replaces the old registration IDs field. Yet the value for this field is a registration ID. And the message identifier, this is an important concept. It is unique per message, it's mandatory, and it has to be set by the third-party server. And the reason is really simple. On the HTTP interface, that's a synchronous protocol. You send a message, and we give you back a response to what happened to the message. For an XMPP, this is streaming. It's completely asynchronous. So you can stream down messages, and we have to tell you what happened to those by giving you back an acknowledgement. And so to make sure we are talking about the very same message, then we use this identifier. So I was talking about streaming. So now the surf server is streaming down messages as fast as you can, and now GCM processes this message. As soon as it processes a message, it replies with an acknowledgement, or with a negative acknowledgement if something went wrong. Well, the acknowledgement is a simple message stanza, and the three fields inside are the from, which is the registration ID of the device we just sent the message to, the message identifier, which is what I just talked about, and the type is ACK. For the negative acknowledgement, there is an extra field, which is error, and tells you an error code that gives you a hint of what went wrong, so you can correct it and send it again. So I was saying how you can stream 4,000 messages per second via this interface. But we give you more. We give you up to 10 parallel connections, persistent connections, so you could actually reach 40,000 messages per second streaming. But not just that. You can use also the HTTP interface, and you don't have to decide a priori which one you want to use. If you need multicasting, go HTTP. If you need streaming, go XMPP. If you want to go insanely massive throughput, then use them both in parallel. Just have fun with it. Well, the XMPP interface will acknowledge or negative acknowledge every single message, and all the GCM APIs that you know about are supported by the XMPP interface except for multicasting. Now, the XMPP endpoint allows for a nice side effect. So GCM can reach back to your server anytime it pleases. So this leads me to introduce our next big feature, which is Google Cloud Upstream Messaging. Thank you. This feature looks like the one before, except now the application streams the message back to the cloud via GCM. If you think about it, it's like if we were providing you with a virtual persistent connection between the Surf server and every single application installation on any Android device. And the best part is that we manage this for you. And it's also reliable. We use the same reliable message queue technology that makes GCM such a reliable system today to stream messaging back up. So your application doesn't even need to think, oh, is there data? There is no data. Just give us the message. We will deliver it upstream. So I was just surfing Ocean Beach this morning in San Francisco, and I had a pretty good session. I was stoked, so I decided to say, OK, this is my new surf location. So I click on the app, and the app sends this message to the GCM framework. Now, the first thing it does is store it locally. So if there is no network, as soon as data connectivity comes back, we can deliver to GCM on the cloud. On the other end, as soon as GCM on the cloud receives the message, well, it stores it locally there. So if the link between the Surf server and our XMPP endpoint is down for whatever reason, as soon as it comes back up, then we can deliver it. Now, one thing we are really big in GCM is we want to make this really simple. So the API to upstream these messages, it just looks like this. You instantiate a Google Cloud Messaging object, you invoke the send method, and you're done. There are 3 parameters. The 2, which is the project ID that the Surf server used to authenticate with our XMPP endpoint. The message identifier, again, is set by the application and is unique per message, and the payload. But now we wanted to provide you with another API on top of this, which is time to live. We think that fire and forget messages for upstream are really important. And it just behaves like the cloud counterpart of this API. So I'm cruising down the coast on the Wine. I'm doing a surf safari, and I tell my app, hey, keep me up to date for the next 30 minutes about tide and swell. And then if I'm in an area where there is no network, then 30 minutes later, GCM framework just drops the message. If instead there is a network and I bring it up to the cloud, well, if the connection between the GCM server and the Surf server is down, then 30 minutes later, the cloud is going to drop the message. So here is how we use the API. It is the very same send method is overloaded, is an overload of this method. And then you have 4 parameters, and the 4th one is time to live. The values are the same for the cloud. It is 0 seconds up to 4 weeks. And if you specify a time to live value of 0, then neither GCM framework nor GCM on the cloud will try to store the message locally or on the cloud. Now, if you send a message with time to live equals 0, but we know that there is no connection, well, we tell you right away. Because we just dropped the message right there. So we give you an error of no connection. Also, messages from upstream, they abide by the same rules of messages from the cloud, which means there is a maximum payload. And this payload is 4 kilobytes. So if you send us a message which is 5 kilobytes, we just return you, hey, we can't, message is too big. Also, we just can't keep collecting messages on the device indefinitely. Right? If there's no network, after 20 messages, we just reject your 21st, saying, hey, there are too many of sending messages. Try later once we flush this queue. So how do we give you these errors? Well, we send the message to your broadcast receiver that you already have to receive messages from the cloud. We give you the message identifier so you know which message we are talking about, and the error code. OK, now let's assume everything went well. My new surf spot favorite, San Francisco, goes up to the cloud. and now we are streaming it to the surf server. Now, what we expect is that the surf server acknowledges this message to us, just like we did for the downstream part. And the acknowledge message just looks like the same. We have 3 fields. 2 is the registration ID from which we got the message from, the message identifier, and the type is ACK. So we are storing messages on the device and on the cloud during the upstream process. When do we get rid of those? As I said, we say new favorite location, it is stored, we give it to GCM, and now there is some selective ACK process going on the reliable message queue technology that we have. So when this process happens, and GCM tells on the framework, hey, yes, we are all done, it's safely stored, then GCM framework removes it. The same way on the cloud, when GCM sends the message to the surf server, and then the message gets acknowledged, then we know that you received it and processed it, so we just safely remove it. If you don't acknowledge the message, we just keep on replaying back to you. Now, acknowledging, therefore, is required. And we pile up to 100 messages on the cloud for one project, for one device, until we start overriding those. So if you fail to acknowledge messages, after a while, you might start losing them. Also, if your server is disconnected for more than 24 hours, we deem your server as gone for good, and we drop every single upstream message until we see your server again. So this connection is pretty good, allows you to send messages back up, is reliable, and so on. But there is another really cool part to it. It's the fact that finally, we have knowledge of what's going on the device. Most likely, your app is not the only one that uses this connection. So we see messages flying through this connection upstream. And what we can do is all those smart things. A simple one is, well, we can delay a little bit and batch them. So we can minimize the time that the radio state is in high power mode. And this improves battery life. But not just that. We also know what's happened for this device on the cloud. So you have the complete picture now. And so we have batch messages on the client, batch messages on the server, and then the first one that starts to send messages, then the other one can also piggyback on this connection and flush it down. So we have a way to send messages upstream reliably. It's low latency because our connection is there, it's encrypted. You don't have to open your HTTP with SSL and so on. And also we provide a time-to-live API. And as I was saying, we are really big in making things simple. So we really don't want you to say, OK, let me think. This is Jelly Bean, so I can use upstream. This is Honeycomb. Maybe I can use something else. We want to provide everything from all GCM-enabled devices from day 0, which is from Froyo Plus. So now I'm announcing how Google Cloud Messaging met Google Play Services. We moved the GCM framework code into Play Services, and there's no reason to freak out because the new library is compatible with the old library and vice versa. It always works. So if you have an application you don't want to touch it, it will work now and in future devices as well. But if you want to use these new features, then you can code it from Froyo Plus from every single device out there. And also, we can always keep this library compatible going forward because all the Play Services updates, they bring them down from Froyo Plus to whatever device and release we are on. Of course, if you want to use the new API, then you have to code against the GCM library on Play Services. I was saying that we want to make things simpler. So we took the opportunity to simplify also the registration process. Until now, you had to declare an intent receiver on the manifest, create a broadcast receiver for your registration, send an intent, receive the registration, and then block with an HTTPS call to the server. Well, we just decided to provide a new method, which is register. You pass the project IDs, the sender IDs, and then what you get back is the registration or an exception. So this allowed us to remove all the code from the manifest for registration, and now only thing you have to do is declare permissions and the receiver for your messages. But more, a lot of applications today, they try to register multiple times. Maybe they lose the registration ID, maybe they want to make sure they still register. So what we are doing in this new method, when we accept a registration request, we send it to GCM on the cloud, we generate it, and then we store it locally in our cache, and then we give it back to the application. So next time the application wants to register, then we serve it from our cache, and we avoid network hits. But because of that, we need to make sure that our cache is consistent with our servers. So when we deem that is the best time to do so, like maybe we are exchanging batches of messages from the device to the cloud and vice versa, then we also start a synchronization process in which we make sure that the registration in our cache matches exactly the registration on the server for this device. OK, so now we have an XMPP connection from your server to GCM. We stream down messages as fast as you want. We have the application on every device, and Froyo Plus, these upstream back messages tell us, hey, new surf location, perfect, whatever. We can start doing something cool. You know, today we have a problem, which is a lot of users start having more than one device. That's not the problem. But it's common to have a phone, a tablet at home. Some people have things called phablets. Lately, I've seen a lot of people wearing smartphones on their faces. And they talk to them, too. So whatever. So my friends are out there surfing. It won't make me jealous. I say, dude, today was classic. And I see this message, and it's fine. I'm really happy for them. But then when I go home and I swipe my tablet on, and I see the message again, then I look up to the right, and it's waiting for me here. And then I go to the website. I want to check the webcam, because I now want to go surfing, and the message is still there. You know, 1 time makes me jealous. 5 times, a little bit too much. So we want to provide an API to make it simple for you to dismiss this notification after the user interacted. So what I'm going to announce now is the new Google Cloud Messaging API, user notifications. Now, this API has 2 parts to it. Today, if the server wants to send a message to me, Francesco, the user, right, it has a mapping of username, all registration IDs, and then send a message, probably a multicast message to GCM, and then GCM delivers it. What would be really cool if the surf server could say, hey, GCM, send this message to Francesco. And then GCM figures out which devices I have, and then delivers it. Well, because if we do this, we can do really smart things. Right? So GCM receives the message for Francesco, and now he knows that I have 3 devices. 2 of them are idle. 1 is active. And so we can send to the active one and keep the message for the idle ones on the cloud. Because all we want to reach is me, not particular devices. But even better. So imagine that now all my devices are idle. But yet GCM knows that this one was active 60 seconds ago. And the other 2 are actually 80 miles far away from this. They're in Santa Cruz, in my house. So if I have new message coming in and I want to ding the user, well, most likely, I'm going to send a message to this one device. And I still keep the message on the cloud for the other 2. So how do we do this? Well, we need to transfer the knowledge from the third-party server to GCM about the user and his registration IDs. So we provided a new API and a new endpoint to do so. It's an HTTP endpoint. The URL is android.googleapis.com/GCM/notifications. And here you can see the header. Classic authentication is project ID API key. And then in body, you have a JSON protocol. Now, the operation is create, and a notification key name is the user. And now we don't need to know who the user is. So please give us a hash of whatever username or email address that you use to identify him. And then the list of registration IDs. And then back, we give you a notification key. So if the user installs the application on a new device, then you can use the add operation to add a registration ID to a key, or vice versa, remove to remove a registration ID to a key. So now that we have this knowledge, how do we send a message to a user? Well, it's the same thing, except in the 2, rather than having a registration ID, now you have a notification key. And now to the cool part. If we give the notification key to our devices, well, then the device can send an upstream message to the notification key, so GCM can reach the other ones. And to do so, we can use the very same user notification API. So you send, hey, send this message to Francesco, and the payload contains the notification key. So now all my devices has the notification key. What I can do now is I receive the message from my friends. It was awesome surf session. So I see it, and then as the Google Play director, Chris Yerga, would say, swipe it away. And so I can send an upstream message to a notification key saying, OK, this notification has been read. And so you can dismiss it on the other devices. And now GCM delivers it to the other devices. Or even more, if you specified so in the notification key, we also deliver it to the surf server on the cloud, so you can remove it from your web properties or whatever other channels that you might have. How to use this API is simple. We use the very same send upstream, and the to, instead of being a project ID, is a notification key. And you can also use the time to live API for this one as well. We can also do some optimization. As I said, I receive a message. I note that 2 devices are idle. 1 is active. So I send to 1, keep the message on the cloud for the other 2. And now I read the notification. I dismiss it. And I send an upstream dismiss notification key message. So now all that we need to do is get rid of the messages on the cloud. Now this saves 2 network hits, 1 to send, 1 to dismiss, for both devices. The notification key is intended to be used to group registration IDs of devices for one user. So we allow maximum 10 registration IDs for a notification key. The notification key name has to be unique, the hash of the username or email address. And this API is available for both the XMPP and the HTTP endpoints. Well, 4 weeks ago, I was talking to a colleague, a friend of mine. He's an Android engineer. His name is Chris Wren, about this API. And he was really excited. So a couple days later, he sent me a video of a really popular application, which is Google Calendar, and what he did with this API. So this morning, actually, he sent me another video, which is a little bit better than that one, to show me what he did on this application. So we have 3 devices. This is a calendar event. You swipe it on 1. It goes away on the other 2. Now we have more than 1 event. You swipe 1, and the other 2 devices just get rid of that exactly 1. And then when you swipe all the notifications, because there are all calendar notifications, then the other 2 as well, get rid of that. Well, thank you. I hope I got you guys excited. I think these are really, really cool features. If you want to read more about this, just point to developer.android.com under the Play Services and Google Cloud Messaging section. If you want to get ready and start using these APIs, please do sign up on this form. We will roll out a whitelisting for the next couple of weeks. I'll take all the questions offline for the next 30 minutes at the Android booth office hours, and I'll leave you with a beautiful map of the Monterey Bay. I hope you enjoyed this speech. Thank you there so much for listening.